In this video, I'm going to cover the material that starts on page 57 in Part B, which is about graphing functions. It looks like they're introducing you to the two-dimensional coordinate plane, but I hope that isn't true. I hope you already know how to graph points, but just in case you don't, let's have a little review. First of all, you are probably familiar with the number line. Here's a number line, and that shows 0. And then you would put marks almost like a ruler for the positive numbers, and then there would also be marks down here for the negative ones. So if I wanted to plot point 2.5, I would put it about there, but just draw a circle there, and that would be where 2.5 was on the number line. If I wanted to plot -3 on the number line, I would put a point there, and that's how I would plot number 3. Not quite on there, but I can't do it with my finger. Well, the two-dimensional coordinate plane, which is also called the Cartesian coordinate plane, is simply two number lines that form right angles to each other. We call the one that is horizontal the x-axis, and we call the one that's vertical the y-axis. Let me draw them a little bit more nicely. Well, not so straight, but more nicely. This divides the coordinate plane into 4 quadrants. Quadrant 1. In quadrant 1, you'll notice that all of the x values are positive and the y values are also positive because on the y number line, the positive numbers go up and the negative numbers go down. So in quadrant 1, everything is positive. In quadrant 2, you'll see that x is now negative, but y is still positive because we're above the x-axis where the positive numbers are. In quadrant 3, we still have x negative, but now we also have y negative. And finally, in quadrant 4, we have x is positive again because it's to the right of the y-axis, so x is positive, but y is negative. And so in the two-dimensional coordinate plane, you have every possibility. Both are positive in quadrant 1, both are negative in quadrant 3. X is negative, but y is positive in quadrant 2, and x is positive, but y is negative in quadrant 4. Because we're plotting in 2 dimensions, we need 2 numbers, a number that tells us where to go on the x-axis and another number that tells us where to go on the y-axis. By convention, that's called an ordered pair, and by convention, actually, the x number always goes first and the y goes second. So if you look at the practice problem number 2 on page 58, they want you to plot 3, 5. Well, since 3 is x and 5 is y, first of all you would go over 1, 2, 3 to find x, and then you would go up 1, 2, 3, 4, 5 to find y, and that rather large dot shows where the point 3, 5 is. Another one they want you to do in that practice is for -1. So again, 4 is the x, so you would go 1, 1, 2, 3, 4, and then you would just go down to -1, and there is 4, -1. Again, I really hope that you already know how to do this, but you are now ready to do the practice number 2 on page 58. Now, on page 58, there is an example 3 that consists of 2 different graphs. The first is the graph of a line, and the second is the graph of a parabola. I hope that you have learned the formula for a line. That is y equals mx plus b, where m is the slope of the line, or the change in y over the change in x, and b is the y-intercept, or the place where the graph crosses the y-axis. So this is the formula for a straight line. And the first graph in example 3 is a straight line. The second one, however, is a parabola. And this would be a very important parabola to learn. You can draw this parabola anywhere on a nice piece of graph paper if you only know a few points. The basic parabola is y equals x squared. Those are the ones that you were having trouble with. So what you start to do, you realize that the f of x equals x squared is a good way to approach this. So let's plot f of 0. What would f of 0 be? Well, it would be 0. There's 0 right there. Let's plot f of 1, and f of 1 would be 1. So that means x is 1 and y is 1. So there we go. F of minus 1 would be 1 because you're squaring it, so that's over there. And they should be, exactly, but, of course, this is me doing it. F of 2 is going to equal 4. So we go over x is 1, 2, and then we go up 1, 2, 3, 4 to there. In a similar way, f of minus 2 is also going to be 4. 1, 2, 1, 2, 3, 4. And you start to see the parabola taking shape. Perhaps it would have been better if I didn't have any of this negative part of the y-axis. So you're actually ready now to do practice 3 on page 59. When you recognize the formula for a straight line, of course you can always put a 0 in for x, and that will give you the b. If I'm looking at number 1 under the practice, and if you put a 0 in for x, then y is equal to minus 1. So you have one set of points to plot, 0 and minus 1. And then, since it's a straight line, you only have to put any value in for x and calculate the y, plot those 2 points, and draw, use a straight edge to draw your line. And I'm going to leave you to deal with number 2, which is a parabola. And if you have any questions about that, we can cover that later. This would be a great place to pause, but you don't have to. You could watch the whole video if you want. Now I'm looking at example 4, which is on page 59. And all I'm seeing there is that x does not take on all the values in the world. And so if you look at the graph, you'll see that they've drawn the line because the equation that they're working with is y equals x minus 2, which is the equation of a line where the slope is 1 and the y-intercept is minus 2. And so you can see that the dotted line crosses the y-axis at minus 2, and that is indeed a negative 1 slope. So, a positive 1 slope. So they've just drawn a pink box there to show you that according to the values that x can have, which is only between 1 and 4, it's just that part of the line only that is the graph of that particular function. Okay, I'm not sure what the difference between Mon number 1 is and Renshu number 4, because they look really similar to me. But you're ready to approach all of these problems. There's 3 little problems there, and it would probably be a good idea to do them. And another good place to pause. Now when you turn the page to page 60, you see that now they're talking about the range of a function. The range of a function is all of the legal values that y can have. This is the same function that they plotted on page 59, and then in that case we looked, they selected that line segment based on the values that x could have. Now they're showing you that because x is limited, y is also limited. And that's basically what they're showing at the top of page 60. And that limitation is called the range of f of x. And I think they have written it there. No, I don't see it, so I'm going to write it for you. It's kind of a bright color, but the range of y for this particular f of x is -1 less than or equal to y less than or equal to 2. This means that y will not ever have a value of less than -1, and it will never have a value greater than 2, but that it can have any of the values that are in between. Okay, going on, the big change that I see in example, what is that? Lady number 1, is that now the domain of x has an inequality in it. So they're showing you the function, let me get a better color, y equals 2x minus 7, and they're saying that 1 is less than x, which is less than or equal to 4. So when you plug 4 into the equation, we could call it f of 4 equals 2 times 4 minus 7, which is going to be 1. You have a boundary for the range of y, but when you plug the 1 in, f of 1, which is going to give you 2 times 1 is 2 minus 7, which is -5. -5 is not included in the domain in the range of y, because 1 is not included in the domain of x. And that's about all I can make out of that. And I think that you're ready to do through Renshu number 5 on page 60.